This is just a quick video demonstration to illustrate the difference between the way dissolved oxygen has been applied to wastewater up until now and the highly concentrated dissolved oxygen method that we are proposing. The difference between the two methods is clearly efficiency. In the first demonstration, I'll just blow air into a tub of water, and you will be able to see clearly the off-gassing. The off-gassing in this little demonstration is exactly the way it works in a larger mix, except in those mixes they use hundreds of horsepower motors to blow that air. Those current standards are called 10-state standards. They're design standards engineers use, but it is literally to blow air and to blow enough air to result in enough dissolved oxygen to treat a mixture. In the case of highly concentrated dissolved oxygen, instead of blowing air, the air is introduced as an emulsion. The gains are twofold. First, the obvious gain, efficiency, is a lot less expensive, so therefore a cost reduction. The second component, though, is because it stays in the mix, the mix has an opportunity to provide that dissolved oxygen to the nutrients, and it dissolves those nutrients, particularly in the form of organics. It just literally dissolves them out of the mix. It turns them into either H2O or a component of CO2. But nevertheless, the result is a large percentage reduction in the amount of waste that has to be dealt with. That means halt. So in this demonstration, I will first blow air, and I'll ask you to forgive the noise level in advance, but I want to say also that in a wastewater plant or in a place where they're blowing air, you have to wear earmuffs. So on a scaled down version, that air, the noise from injecting that air is pretty much the way it is. So let me just begin by turning on the pump. And I will show you what that looks like. So as you can see clearly, that is a tremendous amount of energy for what little oxygen stays in the mix thereafter. Now let me demonstrate what happens when you apply the same amount of, greater amount of oxygen using the emulsion method. And again, this is just a small demonstration to help you visualize, that's all. As you can see, in this case, the emulsion that we put in is just literally staying in place. And because it stays in place, it gets to work that much longer on helping dissolve the nutrients, including phosphorus, that ultimately make their way into wastewater. The result is that we can reduce expenses by 50 to 80%. We've actually done better. And phosphorus is a much more manageable issue. So that's the difference between HCDO and the 10-state standards.